All right, welcome aboard. Today we're going to be talking about an integral u sub example, and we're going to do a harder example for this tutorial. We're going to break this down for you BRNY style right now. So here's our expression: 1 over y plus 1 over k divided by 1 minus y over k dy equal to r dt. The reason we're saying that this one is going to be a harder example is because we're going to be dealing with constants that are not directly associated with the type of integral that we're going to be taking. We have k's over here with dy, and we have r's over here with dt. But don't get discouraged, we're going to knock it out nice and easy. As far as we can see right now, there are really just three expressions in this entire problem. Expression A is 1 over y. Expression B is 1 over k divided by 1 minus y over k. And expression C is r. So let's break this down by our components. Nice and easy now. We're going to integrate both sides. The integral of 1 over y dy is the ln of y. And now component B, we have the integral of 1 over k divided by 1 minus y over k dy. Let's get into this one. Let's pull that 1 over k out of the integral because that's our constant, and that's going to leave us with the integral of 1 over 1 divided by y over k dy. This is a great opportunity for the u sub right here. So let's go ahead and make u equal to this entire expression right here. U is equal to 1 minus y over k. Next, for our u sub step, we're going to take the derivative of that u. Derivative of 1 is going to be 0, so that's gone. And what we're going to be left with is y. The derivative of y is just going to be 1. And we're going to be left with our denominator k because it was a constant. So that was 0 minus 1 over k, and we just get rid of the 0. Our du is equal to negative 1 over k dy, and if we want to solve for dy, all we got to do is multiply by negative k on both sides, and we end up with dy is equal to negative k du. So now we're going to sub this information back into our integral. The original integral was 1 over k, so it was 1 over k, times the integral of 1 over u, this time because u was equal to the entire expression. And then we're going to sub in for dy, negative k du. So here's our new integral that we're solving for here for component B. We have this negative k here. We can pop that out also as a constant, leaving us with negative k times 1 over k times the integral of 1 over u du. This is starting to look a little bit cleaner now. This part, pretty basic right here, negative k up top, k on the bottom, everything cancels and leaves us with negative 1. And the integral of 1 over u du is equal to ln of u. So all we have to do now is sub back in our u value, which was 1 minus y over k, and we'll be left with our final expression for component B. That's negative ln of 1 minus y over k. All right, component C is the integral of r dt. Well, r could come out of the integral here, be kept as a constant, and we'd just be left with 1 dt. And the integral of 1 dt is just t. So it's going to be r times t plus c, because we'll add our integration constant here. So now let's put all of our components a, b, and c back together. We're left with ln of y minus ln of 1 minus y over k is equal to rt plus c. And we're solving for y here, so we're going to raise both sides to the natural exponent e. When we raise each of our components to the natural exponent of e, we get to use that fun rule where we say e to the ln of anything is just equal to anything. So when we raise e to the ln of y for component A, it's just equal to y. That's all going to be coming across to this other exponent rule here on the right side where we have e to the rt plus c. E to the rt plus c is the same as saying e to the c times e to the rt. And since e to the c is just going to be a constant because this e is a constant and our c is a constant, we can just pull it out and call it big C. So we'll call the entire right side of this equation big C equal to e of RT. This logarithmic rule here with the natural exponent also applies to here. So if we have ln of anything, e raised to the ln of anything is just the anything. So our component A, e raised to the ln of y is y. Our B component, e raised to the ln of 1 minus y over k, is just 1 minus y over k, is equal to our C component here. E raised to the RT plus C is just equal to big C E raised to the RT. So our final expression is y minus 1 minus y over k equal to CE to the RT. And that's a U sub difficult example of BRNY style.